Hey guys, good morning. Hope you had a great weekend. This is Mr. Mailhot. I'm coming at you from my office at my house. It's Sunday. I'm getting this video done before the Seahawks game. Let's go. It's snowing outside. We're going to get some work done though. So you should have already watched this video. If not, pause the video and watch that first, and play that video first. But you should have watched that first. We're going to continue our talk about transformations on a graph, but we're going to add in complex numbers and imaginary numbers, not just real numbers today. So we're going to do a few notes and some examples, and you have some time to work on homework from last time, all right? But first, I need you to do a couple things. Number one, like we always do, check in with your group mates, share something good. Hand out the substitute, or one of you guys can volunteer to hand out this paper, and then have your binder open so you got a piece of paper next to it that you can write on, all right? So check in, get this, binder's ready, all right? Go ahead. All right, let's go. So, if I had you do a do now, this would be the question. You don't have a do now today, but you will have an exit ticket. So maybe you write this down on the front, might as well. So what are some things we remember about imaginary numbers? Well, I think probably the first thing, and we've talked about imaginary numbers before, but the first thing probably is you'd say, well, it's the same thing as I, which, correct. And someone probably remember it's the same thing as square root of -1. What else might I expect you guys to say? Probably that if you have from the video. If you have a parabola like this, it has imaginary solutions because it doesn't touch the x-axis, all right? And I grabbed this picture down here from the video that I thought was pretty cool to visualize. So that's what we're going to do today. In your notebooks, you should have this graph paper page on the left, and on the right, go ahead and title the same title that's on the left side, Visualizing Imaginary and Complex Numbers. Visualizing imaginary and complex numbers. All right? We're going to recreate what the video kind of said. You notice here we have a couple things going on. Let's see what good highlighter color. Let's just use red. We're going to look at this axis here. The real axis, the real numbers, or the x-axis, and then this imaginary axis. That's what this first graph here is for. All right? So, for imaginary numbers, and this is what you should be writing down. Graphically, we know imaginary numbers are the square root of -1, and they are used different ways, but on a graph, here's how you create how they come up. Graphically, you use 90-degree rotations from a number on the real number line. 90-degree rotations from any real number on the number line. Let's do it. So this is the real number line. Like, it's not x and y, just real numbers. Well, we do know we kind of already know something about rotations, because if you did starting at 1, if you did a 180-degree rotation, that's the same thing as times by -1, right? But we want to know what's a 90-degree rotation. What's just a quarter turn? Well, that is multiplying by I. Creating, and this is what you can draw, creating this new axis of imaginary numbers. Do that double bar I. Let's make it a little more clear. Imaginary numbers. So if you multiply 1 by I, well, you get 1I. If you multiply, that needs to be lined up correctly, you get 1I. Like that. If you multiply 3 by I, you get 3I, which is kind of cool. Now, back on your notes side, you remember when you learned about I, you learned some patterns, like I to the first equals I squared equals something, I to the third equals something, I to the fourth equals something, and you might already remember what it is. Let's look at how that shows up on a graph, though. We already said I times I, that's first, is I, that's right here. I squared, well, that would be 180 degree rotations, right? 2 turns. And look at what that would be on your graph. Let's start at 1. Let's use a different color. Here's 190 degree rotation times I, and there's your other one. 2 of them. 2 rotations. And what do we get? Well, look at where we landed. -1. We landed at -1. What about I to the third? Well, that's a 90, starting at 1, let's say. A 90 degree rotation, another 90, another 90. So that's 270 degrees of rotation. And look where we ended. -I. And if you remember that from that pattern you memorized in Algebra 2, -I. And look what happens when you go 4 times around. 1, 2, 3, 4. You're back where you started. 1. Or 360 degrees. All the way around. That's kind of cool. So here's what I want you to do. Pause the video for a second. And I want you to just think, let's look at starting with 2. I want you to, over here, what about 2I to the first, and 2I squared, and 2I to the third, and 2I to the fourth? Pause the video, do kind of what we did right here, but start with the number 2 and see what happens, okay? So go ahead and pause and give it a try. Okay, we're back. Check your work over here. Is this what you got? And does it match up with what you had on your graph as well? If it did, you're good. Okay, we know a lot about imaginary numbers. We're going to extend that now. Let's do a new color to complex numbers. Complex numbers. Here's a good definition, kind of an easy to understand definition for complex numbers. Complex numbers are a combination, a combo of a real number and imaginary numbers, of real and imaginary. It looks like this. They all look like this. A plus B I. Yeah, I'm going to write that somewhere else. They look like this. A plus B I. Where the first number is a real number, and the second part is your imaginary part. And that's what the second graph over here is about. Here's your imaginary axis and your real axis. Let's plot some points. We'll plot one together, and then I'll have you plot some on your own, okay? So let's do, here's your example. Let's plot, hold on. All right, let's plot 2 plus 3i. All right. Well, that's 2, 1, 2 on your real axis, and 1, 2, 3 I on your imaginary axis. And it works just like a regular coordinate plane, like XY, but we're not XY, we're real and imaginary. 2 and 3 I. I would be there. And even if you want to label it 2 plus 3I. Actually, let's do this. Let's just say this, instead of an example, you can add this to yours. Let's say this is problem A. So here's point A. All right? How's that? Okay, here's the ones I want you to try. Ready? For B, let's do -5 plus I. For C, let's do -3 minus 6I. And for D, let's do 7 minus 2I. Pause the video for just a couple minutes. Check with each other. See if you can get these points. All right? Go ahead and pause. All right. Check your work. Did you get those spots? If you did, you're on the right track and we're ready to move on. So the last thing we're going to look at, and then I'll have you try a few again on your own, are what we're going to call, let's do one more color, and we're going to use the same graph, scalar, and I think we've heard that word before from our video, beginning of transformations, scalar multiplication. We're scaling things up, making them bigger or making them smaller. Scalar multiplication. So here's how the problem's going to look. Let's say let W equal some complex number like this, 3 plus I. And the goal is, well, find and graph 2W. What's twice of that? Well, we could do it algebraically. It'd be 2 times 3 plus I, right? 2W would be 2 times 3 plus I. We'll replace it, substitute it in, which would be 6 plus 2I. Algebraically, that's what it is. But let's look at it graphically, all right? Here's 3 plus I. There's 3 plus I. And we can even draw a little out to it. Or, you know what? I kind of like how we did it the other day, like this. There's 3 plus I. Now graph 6 plus 2I. Look at that. They're on the straight line. They're just a linear transformation of each other. Right? They're on the same line. They got stretched out. This W point went to 2W. They're just, the line remained lined. It still lines up with the origin. Yeah. So, again, try this, okay? Hold on. Let me pause the video and write your problems to try. Hold on. Okay. Here's 2 problems for you to try. Take the next maybe 5 minutes. Try about 5 minutes. You probably don't need that long. 5 minutes. Find and graph these 2 problems, all right? Use the one we did as an example. Go ahead and pause the video and give them a try. Okay, let's check our answers. Algebraically, you should have got, for the first one, right here, -6 plus 9I. And for the second one, you should have got right here, -1 plus 4I. Now let's look and see how that looks on a graph. I know the graph's getting kind of messy, but here's what we got. Here's the first one, V and 3V following this line here. And notice they're still lined up, linear transformation, like emanating from the origin. And for J, here was J, and here is -J, which is kind of interesting. Like -J went positive, but the original one was negative, so that kind of makes sense. And again, they're lined up, they're linearly transformed, and actually like as if you moved it through the origin, which is, that passes that second test. All right. If you remember the video we watched first, they talked about vectors. These are basically vectors. And that's kind of where we're headed next, okay? So we'll get some more practice with this next time. Let's zoom out so we can see what we did. Pretty cool. This video is on our Google Classroom if you want to go back and watch and tidy up your notes. For your exit ticket, do this. Make a drawing that shows the first 5 powers of I. A drawing. And this picture gives you a little hint, okay? So, I'll see you next time. Good luck. By the way, answers to our other homework from last time are on Google Classroom as well. See ya!